Hello, so this is an introduction to forces. Now, this is really for GCSE level, and it extends a little bit from Key Stage 3, so from maybe you've done it in Year 7. Now, forces from a very early age we're taught are a push or a pull. And so forces are able to change the speed or shape of an object. So they're incredibly important. Now we can split these forces up into contact and non-contact forces. So a contact force, as the name suggests, is a force that's applied when it is touching, when two objects are touching. And then we have non-contact, and this is forces applied when they are physically separated from each other. So contact forces that we are familiar with are forces like friction. When you're walking around, you've got that friction between your shoes and the floor. Friction in the air, of course, we've got air resistance. That's why cars are sort of streamlined. We've got tension. These are all examples of contact forces. One that you may not have come across before is what we call the normal force. Now, or the normal contact force. This is a force that is when it is at 90 degrees to an object that is touching. And it's normally, more often than not, opposite to weight or gravitational forces. So that's the one at 90 degrees. So for instance, if we have a table and a box or a book on that table, we're going to have weight, wrong one, we're going to have weight, and down, that's from the gravitational forces, but at the same time we're also going to have here our normal force, and that's at 90 degrees. Now our non-contact forces, like we said, they can be physically separated from each other. So that is our things like our gravitational forces. Now we try and say that rather than gravity. Maybe even electrostatic. Have you had a static shock before? It can jump from an escalator or a trampoline. Magnets, magnetic forces. All of these are non-contact. Yeah, if you've got those toy trains with little magnets on to couple them up, you can move the trains around without the magnets touching. So we've got contact and non-contact forces. Now, following these, right, we can also look at what we call scalar and vectors. Now, a scalar is different to a vector because a vector has got size and magnitude. Size or magnitude is the same thing, and direction. A scalar has just got magnitude or size. And you might have seen vector in Despicable Me many years ago when you've got the villain there. When you've got the villain, that is called vector. Yeah, so magnitude is also size. So scalar, examples of scalars, when we think of our, what we measure and things, scalars are anything that we've got without direction. So for instance, mass. Mass is a scalar compared to weight. That is a vector. Time is a scalar. Density, temperature, all of these are scalars. Vectors, might include examples like weight. So then we can look at, and really any other forces from that. So the mass, units of mass, remember, are kilograms. Remember, it's a little k, not a capital K. Time in seconds. Density might be in grams per centimetres cubed. Temperature might be in degrees Celsius. Weight there in newtons. So you might be asked other examples that are opposite from each other. So we've also got scalar as in speed, because we give a speed in meters per second, we don't give a direction. But we can do. And then we call speed, we've got a direction, we call that velocity. So velocity is also measured in meters per second, but it's speed in a given direction. Which means you can be going at constant speed, but changing velocity. So imagine we have a roundabout, and you're going at a constant speed around the roundabout at 20 meters per second. As you go round it, you're going to be constantly changing direction. So when we've got a direction here, it could be north, east, south, west. It might be up or down or left. It might be a compass bearing like 5 degrees. But speed is a scalar, velocity is a vector. We can go in at constant speed but changing our velocity. And we might also come across distance. Now distance is a scalar, it's measured in meters, but we can also sometimes, later on with some more calculations, we can look at it and refer it to as displacement, again in meters, but it is a vector. So an example for this one is potentially that, well, you might leave your front door, and you might walk out your front door, go up the road, go round the corner, come back again, come this way, go over here, alright, because there's some cars parked, and go round, all the way around here to collect your football. Now, if this is the case here, your distance will be the total distance that's travelled on that dotted line. So your total distance might well be, let's say that is 40 metres. But your displacement is a straight line from your start point to your finish point. So that is your displacement, which might only be 5 metres. Now you think of a normal school day, you would leave your front door and you'll go to school, maybe by bus, maybe you walk, maybe by car, maybe you cycle. And then you have the whole day at school, you're walking around the school campus, going to different lessons. At lunch, walking around while you play football, you cover a large distance and then you return back again. So in terms of meters, you might do thousands of meters on a normal day at school, but because you've returned to the same point as where you started from, your displacement will be 0. Okay, so I hope that helps you understand and look at the relationships between contact forces, non-contact forces, and scalars and vectors. But remember, with a vector, from very early days, we learned to draw forces, what we call a free body diagram, with an arrow. And that arrow points in a certain direction. And it's also a certain size. So we know if we have a free body diagram like this, and that is 1 Newton, that's going to be 4 newtons. So it's got direction, but it's also got a size. So we can redraw this like that. And our resultant force here is going to be 3 newtons. Now, I'm going to do a later video more on resultant forces, how we can calculate these examples. and other examples as well when we look at vectors in more detail. So I hope this helps you understand it a little bit more, and I hope you subscribe and prepare yourself for more videos to help you understand the introduction to forces.